All right, so we're doing another activity from the active calculus. And so in this case, we're looking at activity 3.4.2. And I just wanted to be sure that we all had the right solution for that. Um, so we're looking at activity 3.4.2. We're making a soup can. So a soup can is going to look like that with radius r and height h, right? And let's see what we're told about this. Um, we want the volume to be 16 cubic inches. And we're given some costs for the tin, or, well, it's not tin anymore. I guess I'm not sure what it's made out of. Cost for the materials for the can. So we need some area numbers, right? So the area of the top is pi r squared. Area of the bottom is pi r squared. So the lids are costing 0.027 cents. Well, $0.027 per square inch. And so for the tops, we're going to have a cost for tops, top and bottom. We're going to have 2 pi r squared, that's the area, times $0.027 per square inch. Okay, the sides, right? If you were to cut this can open and unroll it, right, it would have length or height h, and then what would the length be? The length would be the circumference of the can, and so a circumference with radius r is going to be 2 pi r. So the area here is 2 pi rh, and then we have times we're told it costs $0.015 per square inch. Okay, so now if you add those two together, you should get the full cost. But the problem, of course, is that we have both r and h. So is there a way we can put this together? Because again, the cost is going to be 2 pi r squared times 0.027 plus 2 pi rh times 0.015. And again, the problem is that you have a r here and an h there, right? So we need to get this in terms of one variable. So what we haven't used yet is the fact that the volume is fixed at 16. So the volume gives us a way of substituting for the h. The volume, I'll write it over here. Oops, I'm kind of hiding it. Volume is pi r squared h. Okay, that's the area of a face times the height. And so if that's equal to 16, then you can write h as 16 divided by pi r squared. Good. So with this, we can remove the h here and instead put in a 16 divided by pi r squared. Good. Now, I think if we simplify our cost function a little bit with some numerical evaluations, we get 0.1696 r squared plus 0.480 divided by r. Okay, so now it's easy to compute the derivative. 0.3393r, that's an approximation, minus 0.480 divided by r squared. Good. Set our derivative equal to 0 and solve for r. And it's not too hard to do that. Let's see. I'm just thinking about the best way to show that. How about if we put 0.480 divided by r squared is equal to 0.3393 r. Then I could divide both sides by r. And so that would be r cubed, right? Let me be clear, that's an r cubed, not a r times 3. Good. So now I guess I could have multiplied both sides by r squared. Oh well. Let's get rid of that by multiplying both sides by r cubed. Good. And then divide by 0. So r cubed is going to be 0.480 divided by 0.3393. Good. There we go. And now our r, let's get a new page. I hate to have to go to a new page, but our r turns out to be approximately 1.123. Okay. And then if you plug that into our formula for h, remember that h was 16 over pi r squared. So if I put that r in here, right, that's 16 over, let's see, about 3. I guess that's too much for a round off, because this turns out to be approximately 4.04. Okay, and so using that r and that h, we get that the can has, well, of course it has volume 16 cubic inches. Whoops, sorry about that. Cubic inches. Radius is 1.123. Height is 4.04. And the cost is, let's see if I can move that over. I've got wires showing up in my video. Let's see, where did I put the cost? Oh, I may need to recompute the cost. Hang on one sec. Okay, the cost was about 64 cents. That's the minimum cost. Good. Now I should say that we have not shown that that is an actual minimum, right? So what's one way of showing that? We have our r here. If we think of the r on a number line, okay, the minimum value of r on the number line would be 0. And then we had our critical point at 1.123. And remember that c prime was 0.3393 r minus 0.480 divided by r squared. Okay, so if I plug in a number that's less than my critical point, like x equals 1, what do I get here? It looks like that's a negative number. And then if I plug in a number that's bigger than r, you can double check this, but I believe it is a positive number. Okay, now this means that it's increasing forever after r and decrease. So the function looks something like this, right? And so it just keeps on increasing on that side. Well, it was decreasing on this side. And so this value is our global, not only is it a local min, it's also the global min at 1.123. Good. And so the global minimum cost, of course, we said was 64 cents. All right, that took a little while. So just as a quick reminder how we got through that. So we were given costs for the sides. Okay, so we plug those into our formula, 2 pi r squared, and then 0.027 was the amount that it cost for the top and the bottom. And then for the sides, it was 2 pi r h is the area of the sides, and we have a cost of 0.015. Add those together for the overall cost. And then we had to find a way of substituting for the h so that we could get our function all of one variable. And the way we did that was we used the fact that the volume is fixed. Oh, 1 second. Somebody just interrupted me, sorry. Let me stop that. Okay, somebody walked in. It's the wrong room. I should have had a sign on my door. Oh well, just goes to show you. Just don't walk into somebody's room. Okay, so now let's go ahead and finish this up. So Once you have a function all of one variable, take the derivative, set it equal to 0 to find the critical points. We found that critical point with a little bit of work, right? Critical point turned out to be about 1.123. And so the plugging it into h, you get the height for that. Oops, there's my can. And so we have the dimensions for the minimum cost can. Just checking the time real quick. And then, yep, we get a global minimum out of that. So that took a little bit of time. Gosh, 10 minutes. See how you do. I'll stop recording here, and then we'll try another example.